Okay, so today we're talking about areas of circles and regular polygons, and I'm just going to go through some example problems since we've already talked about the formulas in class. So, area of a circle, most of you guys already know, is pi r squared. R is the radius. Other formulas you might need to know are circumference. Circumference equals 2 pi r, which you should also already know. Now, when we're talking about a regular polygon, first of all, remember that a regular polygon has all of its sides and its angles congruent to each other. So this is on the bottom here, this blue shape. This is a regular polygon. Okay, all the sides and all the angles are congruent. Now the area of a regular polygon is 1/2 perimeter times apothem. So the P here represents perimeter of the shape, and the A represents apothem. Okay, in this case, I've drawn an example of a regular hexagon. Now, the apothem is the segment that goes from the center of the polygon, and it extends out to the middle of one of the sides. It's always going to make a 90-degree angle on the side. So that's the apothem. It's also always going to cut that side in two congruent parts. Okay, so let's look at an example. Look at a circle example first. Okay, so let's say that I give you this circle and it has a radius of 4 inches, and I want you to find the area. So all you're going to do is simply plug in 4 for the radius. So you can see that 4 is your radius, 4 inches. Here's your formula. You're going to plug in area equals pi times 4 squared. So you're going to get area equals 16 pi inches squared. And that's going to be your answer. Now let's look at the next example here. The area of a circle is 28 centimeters squared. Find the radius. So here you're working backwards. So you're going to start with your area formula. Area equals pi r squared. You're going to substitute what you know and find what you don't know. So what you know is 28. 28 equals pi r squared. Now I want to isolate the r, so what I'm going to do is divide by 28. Divide by pi, so that's what I did here. And you end up with r squared equals 28 over pi. Okay, r squared equals 28 over pi. I'm just going to rewrite that here. R squared equals 28 over pi after you divide by the pi. Now, to get rid of the squared, remember that you have to take a square root. So, square root the left, square root the right. When you add a square root, you have to add the plus or minus. So, on the left side, you're left with r, and on the right side, you're left with square root of 28 over pi. Now, you don't need the negative solution here because we're dealing with a real-world situation. Now, this is a completely fine answer, but what I'm going to do is I'm going to go a little further with my algebra skills, and I'm going to simplify the radical. So r equals square root of 28 over square root of pi. That's this part here. Square root of 28 you can simplify to be 2 square root 7, and then divided by square root pi. And I'm going to get the radical out of the denominator by multiplying by square root pi over square root pi. And that gives you 2 square root of 7 pi over pi. And this answer is a little bit kind of funky and messy, but that's it, okay? And you can plug it into your calculator and get a decimal approximation, but this is your exact answer here. Okay, now let's look at some examples with regular polygons. So let's say this hexagon here, pentagon on the right is given, And the information you have is that the apothem is 6 inches, and you're given this segment here, okay? The rest of it we have to figure out. So remember that area is 1/2 perimeter times apothem. Well, if I know that this part here is 1.5, well, that means this part here is also 1.5 on the left, which makes that whole bottom segment 3. And therefore, I know that's 3, and that's 3, and that's 3, and that's 3, and so on. So my perimeter ends up being 15. The apothem is given as 6. You just literally plug it in. You have area equals 1/2 15 times 6, the perimeter times the apothem, which gives you 45 inches squared. So that's that example. Now, the problems get a little bit harder when you get to hexagons. So, in a hexagon, let's say you're given this, let's say you have a hexagon, and I'm going to erase all of this stuff here. Rework it. All right, so in a hexagon, and only a hexagon, you can divide it into equilateral triangles. Okay, watch what I mean by that. A hexagon has 6 sides, so if I cut this up into 6 triangles, 360 degrees divided by 6 is 60 degrees. That means that each one of these triangles here has a 60-degree angle at the top. Now, if I drop my apothem in, which is an altitude of this triangle, that's going to be 90 degrees. Because this is an isosceles triangle, it cuts this in half, which makes that 30 degrees, and this is 60. So you have a 30, 60, 90 triangle. So this only works in hexagons. So only in hexagons does the apothem make a 30, 60, 90 triangle. So I'm going to give you guys an example here. Let's say I have the apothem, and the apothem is given as 7 centimeters. Now, I know that this makes a 30, 60, 90 triangle. So this is going to be the short leg. This is short leg times 2, and this is short leg times square root 3. And so let's say the question says find the area. Well, I know area equals 1/2 perimeter times apothem. So I need to know my perimeter, so I need to figure out what the short leg here is. So I'm going to set it up. I'm going to say 7 equals short leg square root 3. I'm going to divide by square root 3, divide by square root 3. So these cancel. So the short leg of that 30, 60, 90 triangle is 7 over square root 3. I need to get rid of the radical, so I'm going to multiply by square root 3 over square root 3. So that tells me that the short leg is 7 square root 3 divided by square root 3 times square root 3 is square root 9, and square root 9 is just 3. So that means this part here is 7 square root 3 over 3. And that means that this whole segment is twice that, so 7 root 3 over 3 plus 7 root 3 over 3 is 14 square root 3 over 3. And all of these measure 14 square root 3 over 3 because this is a regular hexagon. Okay, so I could fill in every single side here. And now I know my perimeter. Okay, 14 square root 3 over 3 times 6. Perimeter equals 14 square root 3 over 3 times 6, which gives me 28 root 3 all over 3. And I'll just plug that into my area formula over here. So I've got area equals 1/2 the perimeter, which is 28 square root 3 over 3 times the apothem, which is 7. So what's that going to be? 28 divided by 2 times 7. So area equals 98 square root 3 over 3, and my units are centimeters, so centimeters squared. And if I want to plug that in the calculator and get a rounded answer, you get about area equals 56.6 centimeters squared. And that is it for today.